if you were here last class. So you need to see that new piece. So stay tuned in through that, and then after that, I'm just going to be kind of recording for people that missed it last class or this class, since there's so many people out testing. All right, so we are recording. Let's go to, oh, way up there. There we go. All right. So here's our bell work. Again, this is it's really review from prior year's knowledge, but we also went over this last class. So number one, it says, what is another way you could write 5, and that's pronounced, there's a couple ways you could say it, 5 to the 7th power, 5 raised to the 7th power. That's pretty much it for that one. It just means that you are, so we talked about the fact that, where's the pin? Here we go. This particular number is made up of 2 things. Oh, my board's not working. Dadgummit.
Did you get it fixed?
No. It's not even close to working today. Let's see if this fixes it. If not, I don't know. Oh, I didn't even hit that one. I don't know what happened there. So we talked about that when you have any number, really, variable, number, doesn't even matter. All right, that's not too bad. Every number, every variable technically has an exponent to it, even if you don't see it. So if you see the number 10, there's actually an exponent there of 1. If you see the variable y, there's an exponent of 1. And my pen's already messed up, so this is not going to work very well. But any number, any variable, anything that is a term, a number term, has an exponent on it, even if you don't see an exponent there. We said it was 1. So that's different from the coefficient that's in front of a variable, 2 different things. So therefore, any number raised to the first power, so like you see 10 to the first down here, so that 10 to the first power just equals 10. Any number raised to the first power is just that same number. That's why we don't write the 1. There's just no reason to write it if it equals the same number. There's no math we need to do. Now, when we have different exponents other than the 1, we have to write them. So, for example, we have 5 raised to the 7th right here. So what this means, oh, didn't mean to do that. Let's try that again. There we go. So when we have this, there's 2 pieces to this. There's that, which is called the exponent. And again, this is in a lot of your notes from last class, so that's the exponent. God, this poor smart word is not working well. I'm going to try it again in a second, I guess. So that's called the exponent. And then we said this big number is called the base. Oh boy. So that's B-A-S-E. It looks like a C, but it is not. I'm going to have to type in some stuff maybe. So that's called the base. So you'll hear me say base a lot. That means the big number. And then exponent is the little number that's raised up and to the right. So what, and I'm going to be erasing a lot of stuff. So you guys keep up, because once I write it up there, it's only going to stay up there for a few seconds. So what this overall term means, and again, this is review for you guys. I'll get to the new stuff in a minute. What this term means is we need to, oh boy. We need to take this term it's just off. There we go. We need to take the base. So again, when you have an exponent, what this is saying is take the base number, so the 5. So this is going to equal the base time, and you multiply it times itself as many times as you have for the exponent that's on the number. God, this is all dropping down low. So 1, 2, 3, 4, 5, 6, and then times 1 more. So we have to multiply 5 times itself 7 times because the exponent is a 7. If it would have been a 3, we would have only multiplied it 3 times. If it would have been a 4, we would have multiplied it 4 times. So that's what that means mathematically. It's just a shorter version of saying 5 times 5 times 5 times 5 times 5 times 5. Kind of like addition and multiplication are tied. Like instead of adding a number over and over and over again, we can just multiply. So if we added 2 15 times, instead of doing 2 plus 2 plus 2 plus 2 plus 2 15 times, we can just say 15 times 2. This is similar, only we're multiplying and then converting that to a shortcut, which is an exponent. So that's what answer to number 1 was. Let's see, the product rule. So I said over and over again, oh shoot, I forgot to make copies. Scan. We can get away with it today again. I sent you guys out a packet. We really are only going to use the first page of the packet. It should be in your email if you weren't here last class. If you were, you should already have it. So the product rule says, if we are multiplying terms with the same base, so I always use 2's because they're easy to work with. So we have a 2, that's multiplication, and we'll say that's 2 squared times 2 cubed. It says, if you are multiplying terms with the same base, so again, the base is the big 2. So this is the base, one of the base numbers, and this is the other base number. They are the same. They have to be the same. If you've never written that in your notes, you need to write that in your notes. If they have the same base number and you're multiplying the terms, to get the answer, all you really have to do board is not cooperating, not even close. Oh boy, that was even worse. I just don't know what to do. Try to write really slow, sometimes it works. Sometimes all we do is we add the 2 exponents. So the answer to 2 squared times 2 to the 3rd is really just 2 to the 5th. We just add the exponents. And I said that's the most important rule because from every other rule, we can, if we understand this rule and if we understand number 1 here in the bell work, we can actually just use those 2 things. We don't have to memorize a bunch of rules. We're still going to go through all of the other rules, and that's the main reason I'm recording. But if you understand that 2 squared is 2 times 2, and 2 raised to the 3rd is 2 times 2 times 2, and then if you understand this power rule, that when you're multiplying terms together with the same base, you can add the exponents, you don't really have to memorize all of the other rules. And there are a lot of them. So, but there's no way, for my test, you get to use your notes, so it's not a big deal for my quizzes and tests. Problem is when you go to take the end of course exam, they're not going to give you those rules. Like you have to just, again, either memorize all of them or more importantly, you have to understand how to get the answer without having all those rules in front of you. Which is why I say if you can just understand this one rule and then understand, just what an exponent is in general, you can get by without having to memorize everything. All right, so let's talk about, so again, this is the product rule. We're going to review real quick on the next page what we did last class, and then we'll move forward and do some new stuff. I'm going to try this one more time with my finger. All right, we'll see if that helps at all. So here, well, actually, I think it might be, nope. Now it's working a little bit. So here's what we did last class. I'm going to just walk through all of this real quick. So we said we did the base and the exponent in number 1. And number 2, we said if you see that square root symbol and there's no number, you see where the 2 is? Originally, when I wrote that, there was no number there. So it was just the square root of 9. Well, technically, there's a 2 there. It's kind of like every number or every variable has an exponent of 1. Every square root, every radical, I should say, that symbol is called a radical. Every radical has a 2 there if you don't see a number there. Now, if you look in the upper left, I can use my cursor to kind of point for those of you online. You guys in class can. So if you look in the upper left, whoops, well, that's hard to do from the side. Here, tell you what. I'm gonna sit down real quick. So if you look in the upper left, these numbers under the radical, so again, the radical is this little thing that almost looks like a division symbol. It is not a division symbol. This is not about division. You see there's a 5 on this one. There's a 3 on this one. So there's going to be a number there, and if there's not a number there, then there's technically a 2 there, like right here where my cursor is. So what this symbol means is you need to take some number, so that's what the X is, some number, and you need to multiply it times itself. And then again, you multiply it as many times itself until you get to whatever number you have right here. So on this particular problem, we didn't have anything, which means there's a 2. So that's why we say X times X, some number times itself, equals 9. And then we have to figure out what that number is. Now, there's a button on a calculator you can use for some of these, actually for all of them if you have a really good calculator. In this case, we know, though, that 3 times 3 equals 9. So the answer to the square root of 9 is just 3. That's why the answer is 3. Up here, we need to know what number times itself. Again, this little symbol right here, this radical, it always means, if you guys didn't write this face-to-face, so Joey, there you go. If you guys didn't write this, write it. The radical symbol itself. I'm going to write it down here. Hopefully it will write. This symbol means what number times itself. So basically what base. It's the base number that you're looking for. So what number times itself, and then the number of times you multiply it is based on whatever number is right there. If there's nothing there, then there's a 2 there. If there's a number there, then you'd multiply it times itself that many times. And then the last part is it has to equal what's ever underneath this box. So again, we'll use some examples. I'll tell you what, I'm going to actually zoom out to try to explain it real quick. And again, I'm going to go fast today because we already did this lesson in last class. So this example right here, the square root of 9, there was no number there, so I wrote in a 2. Oh, and we said whenever you don't see an exponent, at least for the next 2 weeks, go ahead and write a 1 in. You don't see an exponent, write a 1 in. If you don't see a number here above the radical sign, write a 2 in. Just like I wrote a 2 in right here and a 2 in right there. So what this square root of 9 means is what number times itself. There's a 2 there, so that's why I have that number twice. And then I take what's underneath the radical, which in this case was 9, and that just goes on the right side of the equation. So if you'll notice in this one, 40 was underneath the radical. Well, 40 just went on the right side of the equation. In this one, even though it was different, it was a variable underneath there, that still just goes on the right side of the equation. Whatever's underneath that radical just goes on the right side of the equation. And then this part is always going to be some number times itself, and then you would do it as many times as whatever this number is. So for example, up here, it's X times itself 3 times. 27 was under the radical, so we wrote 27 right there. And then this one would be X times X times X times X times X 5 times equals 32. And keep in mind, it doesn't have to come out to be a nice round integer. You're going to get decimals a lot when we do these radical signs. Probably you're going to get decimals more than you're going to get just a nice round number. So remember that. It can be a decimal. That's going to happen a lot. And that's pretty much, I think, the whole review. Oh, I didn't even notice this, but up in the upper corner, this thing right here, I wrote it out. So this symbol means what number times itself. And then how many times you write that variable or that number is based on this little number here. and then what the number equals on the right side is based on what's under the radical. All right, so that's your quick review from last class. Now we'll do the one new part. This is something we did not do last class, so tune back in if you were not tuned in. Let me zoom in on this. You guys can't. Can you see that at all here, face to face? Probably not. Oh, you can? I'm still going to zoom in. I'll zoom in. Yeah, there we go. That's much better. All right, so here's the new part we did not do. And I think in the future I'm going to do this part first. So there's some rules. So you need to write all of this down. So everybody write that down. This is for convert. You don't need to write this little thing up here. That was for me to use if I needed it later. Just to drag it. Sometimes that helps keep me from having to draw on the smartboard, which, as you can see, doesn't always work. So you guys at home, write that down also. I've got to make copies today, scan them myself. Actually, while you guys are doing that, I'm going to try to find the original ones so that I can make the copies of it. You guys at home should all be copying that down. Hope everybody had a good Easter at home. We already talked about Easter here in class. When you guys are done, just kind of put your pencil down.
You gotta write these ranges out.
You gotta write everything you see on the board except for what's in that little dotted box. So yes. Actually, I'm going to do it probably during this class. We may need to go over this too, because some of this is hard to see. Almost done? All right, so I'm going to just start talking about this. You may still be writing, but again, this is recorded if you need to go back and look at it. So it's got some weird vocabulary in here. So I'm going to just kind of explain what this means. So it says if the nth root of a is a real number and m is an integer, then all of this is true. So when it says the nth root, the root is what you're taking when you do this. So when we see that symbol, we say it's a radical. It's the root just means you're doing what we talked about earlier. You're taking some number times itself as many times as whatever you see right there. That's what root means. You're trying to figure out like what number times itself and then as many times as you see where that n is, and then equals whatever is underneath the radical. So we would be saying, if we were to write this out, we would say, well, some number x times itself, and we don't know how many times we would write x because there's an n there. We don't know what number n is, so we might just write it twice. We might write it 20 times. You'll really never write it 20 times, but eventually it'll be that number times itself, however many numbers n is, and then it's going to equal a. That part doesn't change because a is underneath the radical, so a will go on the right side of the equal sign. That doesn't change. The only part we don't know is we don't know what number n is. It's just a variable. So we don't know how many times we need to multiply that number times itself. But it's something like that is kind of what it's saying. So that's what all this, and m just has to be an integer. So this number right there would have to be an integer. They can't give you a fraction or a decimal for that number. And then the fact that n is a real number just means that any number is possible for n. So don't worry too much about that. All right, so that's what, actually, I didn't need to do that. So that's what that means. So now let's talk about each piece. So you'll notice there's an A here. Remember, I'm going to write this a little bit bigger. So there's an A, and then there's an N. Well, we already said every number, every variable has a 1 exponent. If you don't see an exponent, there's a 1. So this A has a 1 on it. We're going to write that 1 there. And this is why I tell you to always write the exponent in, even if you don't see one there. You don't really have to write it on the n over here, this. Don't worry about writing it on that, because that's not the base. Every base is what you really have to worry about. So any base number, write the exponent in. So there's a 1 on that A. What it's saying is you could rewrite this term, this square whatever, this root of A. You could rewrite that using just exponents, and get rid of this little radical sign thing. Again, that's the radical sign, that thing. So we can get rid of that and write it where we just have a base and then an exponent. And the way we do that is we take the base, so this is what it's saying over here. We take the base, which is the A. Actually, tell you what, I'm going to write it over here up next to the other one since it's pretty small. So I take the base. So that's the A. That's the base right there. That's the base. And I just write that as my base. Now I need to say, okay, I need to convert the exponent and the root into a fraction. That's what this is doing. It's converting those two things into a fraction. So it's taking whatever the exponent is from the A, which is just 1, putting that on the top, and then it takes whatever is outside the parentheses, this n, and that becomes the bottom, the denominator. I'm sorry, it's not a 2, it's an n, my fault. I'm going to use 2 in a second as an example. So we don't know what n is, so we just have to write it as n right now. So that's what that first piece is saying. To convert something with this radical symbol, this little thing that looks kind of like a division symbol, but it's not. To convert that to a base with an exponent, we just take the exponent that's on the base already. So this 1 goes to the top, and this n goes to the bottom. And now we got rid of that radical symbol. And that comes in handy sometimes on certain math problems. We talked about this before, but they are inverse operations, just like addition and subtraction are inverses, just like multiplication and division are inverses. Taking a root of a number is an inverse of raising a number to a power. So we can use them both like opposites, basically. All right, and we're going to come back. Actually, we'll do an example of that. So if I were going to write, so I'm going to zoom back out a little bit. Okay. So if I were going to take, for example, one that we know, an easy one, number 4, and it's under a radical. And we know the answer to that is 2. That's why I picked it, because we know the answer. If I were going to rewrite that into a base with an exponent instead of something with that radical symbol in it, again, A is the number that we moved over. So you'll see that A right here, we just moved over and that became our base. So 4 would be our base. We just moved that over. Big number is always the big number. That doesn't change. And then we would say, okay, well, what exponent was on 4? Well, there's nothing there, so that means there's a 1. So the 1 again goes to the top over here. And there's nothing here, so that means we would write a 2, and then the 2 would go to the bottom. So if we were to rewrite that, it's 4 raised to the 1/2. All right, so I want you guys to do one real quick. I'll give you a second at home if you're still writing. Have you guys got this? I'm about to get rid of all of it. Again, the key is just remember, I mean, you're going to have this for my quizzes, but I would add notes and just say, hey, the number that's, or the exponent underneath the symbol, well, here, we'll start with this one, we'll come back. The exponent underneath the symbol goes to the top. Again, it's kind of called the root. The root, or the number outside the radical symbol, goes to the bottom. I'll just kind of explain what's happening. If you're trying to figure it out on the quiz day, it's not going to work. You need to explain it to yourself now, so when you go back and look at this, it's easier for you to figure out. Still going? Still writing, or are you done? So that's the way I would rewrite that. I want you guys to do one real quick. And again, this would be the easiest part of this particular lesson. So if you're not getting this, you need to work to make sure you get this, because these would be the questions I would expect you to get on a test. So I'm going to put a few of them on there, and they're going to kind of be your easy points to make sure you get some points on the next quizzes that we do. So I want you guys to do this. If you have this number, and then we'll say this time there is a number there. I want you to rewrite that into a number with a base and then an exponent. So you're basically doing the same thing we just did, only you're getting rid of that radical symbol. So it'll be in the format just like I had for the 1/2. It'll be in that format. Some base number, some big number, which the big number is always the same. It doesn't change unless you change it. Then raise it to, and I should have written that smaller. But more like that. So you're writing a number in that format, but using these numbers. And you should have the example we just did, the one with the 4 underneath there. Just follow that. Put the same, all you got to do is put the same numbers in the same place. Identify which numbers match up and put them in the same place. That's all you're doing. I'll give you a few seconds. It shouldn't take real long. I'm going to walk over and see how you're doing there. Well, this is correct, but you would get rid of the radical. You move the base over first. You don't just write equals whatever.
So that was what you had up there.
Well, what I had up here was this. This was the final. If you didn't write it down, that was the final answer for the 1/2.
No, that was the equation that you had wrote out.
Did you have that answer though written down? I couldn't see it.
No, I didn't have.
Okay, well this was the final answer to that problem when we rewrote it. I just want to make sure you have the correct answer to the other one. You have the 1/3 part right, but we're getting rid of this little weird radical symbol thing, and we should just have a number that's the base, and then an exponent, which was, the exponent would be 1/3. You had that part right. But the base would just be 27. Is that what you have, Joey?
Yeah.
Okay. So I'm just going to rewrite this one real quick. So again, first thing I do is what? What should I always get in the habit of doing? And for the next 2 weeks, every time we're doing an exponent lesson, what should I get in the habit of doing? Yes. If you see a number or a variable without an exponent, write a 1 in. Get in the habit of doing that. I already showed you last class. I think we did that in here. How if you forget to do that, it'll mess you up. And you're going to like add the exponents and you're going to forget to add the 1 in. Or you're going to forget what to do from here. So the answer to this is I take the base, which again, the base is the 27, and I just bring that over. And then to create the exponent, this number goes on the top, this number goes on the bottom. Oh, wait, that's not what I want to put. So the 1 goes on the top, and the 3 goes on the bottom. Always, that is always the case. So if you just have a couple of examples, you should be able to match those up with a problem and be able to rewrite it. Like you've got a worksheet you'll do. Some of these you have to do that on. And I'll tell you right now, I didn't really talk about this because we haven't gotten to this. I'm showing them the second sheet that you guys don't have yet at home. A lot of the quiz questions are going to come straight from this. I might change the numbers, but same exact question that they're asking with just a different problem. So anyway, that's how you do that first piece of it. So now if we look at the second part of this. So the second part of this is really just the same thing. Only all we're saying is underneath the radical symbol. So again, this is the radical symbol. Underneath that, when we have the base number, which is the a, we now have an exponent on it. Like that's what this is. We have an exponent on it now. Instead of there just always being a 1 there, we're going to have some exponent there instead. So for example, we might have a to the 3rd, and then out here we might have a 5. But I do the same exact thing. Nothing changes. If I just want, and again, I'm not solving. So guys, make sure you're clear on that. We're not solving this. Like if I were solving it, it would ask us what number times itself, and times itself 5 times would equal a to the 3rd. But I'm not doing that. I'm just rewriting. I'm just basically rewriting it and trying to get rid of that radical symbol. And I just want a base and an exponent, a base and an exponent. So if I were to rewrite it, I take the base and I move it over. The exponent that's underneath the radical goes to the top. Ooh, that's way too high. So it goes to the top. And then the number outside the radical goes to the bottom of that fraction, the denominator. So that's how you would rewrite it. That's all this bottom part is really saying right here, this and this. You just do the same exact thing we did over there, only now instead of having a 1, we have some number as the exponent. But it still goes in the same place. It still goes on the top, and then the number outside still goes underneath. Now the last part is a little trickier, and I'll have to explain what that means. We could then, so again, let's take the same problem we had. A to the 3rd, there's a 5 out there. We said we could rewrite that to a to the 3/5. So there, we rewrote it to that. It's telling you there's another way to rewrite that. We could take that and we could say, okay, well, I could actually rewrite this and say, let's take the square root of a, or not the square root. Let's take a to the, again, whatever number n is, it's the number outside. That stays the same. The number outside stays the same. It doesn't change when we go from here to here. The variables don't change. They're whatever number they are, that's what they stay. But then the m, so the m was originally this part, the exponent for the base that's underneath there. Then I raise all of that to the 3rd power. And I'll give you an example in a minute and see how that works out. So you wrote all of that down again. the variable m is always the same number. It might change places, but if a variable is in an equation or in a term or whatever you want to call it, it can't be a different value. Now, obviously, if you get a different problem, it could be a different value, but within the same problem, everywhere you see m is the same number. Everywhere you see n is the same number. Everywhere you see a is the same number. Make sure you remember that. So now let's do some number examples with actual numbers, and you'll see how it works out. So if we had, so let's just talk about, I'm going to give you the answer ahead of time so you have this in your mind. So let's just say, I'm going to get rid of all of that. So let's just say we take the number 2 and multiply it times itself a bunch of times. We'll do 6. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So I know that's 64. All right? So now, let's practice and let's do this with the number 2 and some of these different versions here. So what if we wanted to take, so this is 2 raised to what power, by the way? What I just wrote. 2 raised to what power? 6, right? Because I did it 6 times. So we're going to do 2 raised to the 6th power, right there.
Write that down.
Yep, write that down. And that's the problem that we're about to rewrite. So we're going to rewrite it into, we don't have a 1 here, so we won't use this, although it's really the same thing. I mean, it's just, I don't even know why they give you that, frankly, but this is really what we're going to use, because we have an m exponent attached to the base. What's the n value for the problem I just wrote up? The value of n is in Nancy. What will n equal? Well, that's the m, right? Because here, 6 is here on the base. So that m is 6. So we could write that. We could say, okay, well, in this problem, in this particular problem, m equals 6. We know that. What's n equal? What is n equal? Hmm? Well, you're on the right. It's not unknown, first of all. We wouldn't call it unknown. We don't see it. What do we say when we don't see the number there outside that radical? What number is it?
1.
It's not a 1. A 1 is the exponent. If we didn't see it, like here, we don't see a 1, or we don't see a 1 here, right? Well, technically, all of those have 1s. And if you'll notice, we could have added all those exponents up because we're multiplying, and that's how we get 2 to the 6, because we're multiplying 2 6 times. So the exponent is, if you don't see it as a 1, what number is out there if you don't see it? You need to write this in your notes again. I'm sure you have it, but you need to keep writing it so you remember it. What number, if you don't see it outside of that radical symbol, is it? Well, it's not 1. What's the only other unseen number that we wrote in? It wasn't 1.
64.
No, we see 64. That was just to show you what the answer should be eventually. Do parse this. 2. If you don't see a number in this spot where n is, so write this down. If you don't see a number, circle that spot with n there, or circle it with nothing there. If you do not see a number there, it's a 2, always. Always, always, always. Because think about it. When we just do square root of 9, we said that's some number times itself twice, right? Equals 9. I'll just finish writing. So right when we just have the normal square root symbol, we said that's some number times itself twice equals 9. That's how we solve for that problem. The fact that we say times itself twice comes from the fact that there's a 2 there, even though we don't see it. That's how we know to multiply that number times itself twice in order to figure out what the answer is, because there's a 2 there, even though we don't show the 2. That's like, you know what a default is? Like, a default means like that's just the starting point. Like you always start thinking there's a 2 there. If there's not, so we don't write it in because that's what we're thinking is there. If it's not a 2, that's when we have to write it in to show it's not a 2. So what number is there then? What's the end for our problem? Not this problem, the other problem. What's the value for n? N is in Nancy. We already know the m is 6. What's the value for n? It's 2, right? We don't see it there. So that is going to be 2. So now I want you to rewrite this, right? So this piece right here is kind of the middle piece. It's got a radical symbol, it's got a base, it's got an exponent of m, and it's got an n. Now we wrote the n in. I want you to rewrite that into both of these formats. Both of them. Then we're going to do some solving out, and we'll see that we kind of get the same answer no matter what. Should have brought one. You guys all done? Did you already do it? You guys are doing a problem right now. You know that, right? You were supposed to take this and rewrite it into those 2 formats. Did you do it? I didn't think you had done it yet. So again, take this. So we know n is 2. So again, if m is 6, wherever you see m, it's going to be 6. If n is 2, like if you do this process and you go ahead and just write a note saying, well, m equals this, n equals this, then just every time you see n or m, you just write that number. Have you done it? All right, let me grab my glasses. I'll let you, or I'll check your. Good. Now write the second version now. So you wrote this version, you got that one right. I want you to write that one. That's different.
That's what looks right here.
What did you write? Well, no, that's the beginning problem. So that's the middle part. That's the middle part we already had. This is different. You got to have parentheses. Well, no. Actually, no. Yeah, so again, I wrote it. Well, no, I guess that's right. All right, that's fine. I think those are good. Just make sure. In all honesty, I don't remember what you had written down. I was thinking that it should have been something else, but I was thinking I had written something different in my head. So we'll see. We'll just solve it out. So first, we would say, all right, the easy one I think is this first one, because all you're doing is moving one number to the bottom, one number to the top. I keep the same base, and both of you I know got this one right. I keep the same base, so 2 is the base. Oh, we could have written up here too, what does A equal? What does A equal?
2.
Yeah, A is just the base, the big number, right? So now, everywhere I see A, I write 2. Everywhere I see M, so again, I'm doing this one right here, right now. M is on the top. Well, I said 6 is M. N is on the bottom, and I said N is 2. So I almost don't even need to really figure it out. I just look and see where the letters are and look over here, and then I just write them where they're supposed to be. So there's the first one. Now, what could I also say that equals? What math can we do in that real quick? Yeah, we can do that. If you have an exponent and you can do math on that exponent, do it. So that actually we would say equals, so 6 divided by 2, we would actually say that equals 2 to the 4th. All right, so now let's do the second one. So again, I'm going to use this same setup right here. I'm not going to rewrite that. So for those of you online, I'm talking about this. I'm not going to rewrite this. So we're using that problem still, but we're going to write it now in this format right here. Well, I take the radical symbol, write that. So I see what my A is. Well, my A was 2, so that needs to be the base. Now I say, okay, well, I'm putting parentheses around this, which does make a difference. Hopefully you guys did that. What is my n value? Well, my n value is also 2. And then I'm taking that. I feel like I did something wrong. And then I put my m out there. Well, I don't think I did anything wrong. What I mean is I meant to set it up so it came out differently. I didn't. I'll do one in a minute like I meant it to come out. I think I have some tape maybe that you could use, like just that kind of tape. That'll work pretty well. Okay. So now I've converted all of it. Is that what you guys got, that last one? Okay. So let's do one more of those. Any questions on anything there? If you have questions online, you're going to have to unmute because it's not showing me any notifications or anything. So here's the one. I'm going to do one that I meant to do. So now let's say we have this problem. I'm going to write it up. And we'll say that's actually the problem. I want you to rewrite it in both formats. So you're taking that problem and rewriting it again like that and again like that. What's that? Yep, that's the final version. So what do you need to do? What's the first thing you should do? Well, not a 1. A 1 would go here. Remember, the exponent is a 1. This is a 2 if it's missing. So make sure you, again, you may want to write that note.
I do.
Okay, because you just said 1. Make sure you keep writing it over and over again until you get it memorized. What period is this? 4th period?
Yeah. How long you got left?
Normal time. So. Oh, as far as the lesson goes, or as far as the class goes?
The class.
Class is still 35 minutes. We're almost done with the lesson. You're part of it. I'm going to keep going and review it for anybody that missed, and just make sure I get the full recording. All right. So this should be a relatively easy concept. And you can't do any math on the exponent, so that's what we're done. So the reason why all these rules come in handy, that looks good, I believe. There are going to be times when you can't solve a problem in one format, but you can solve it if you put it in another format. Just changing the format allows you to solve it pretty easily. So I'll show you this example is kind of one of them. Not that this is a super hard problem, but if they were bigger numbers, it would help you. Because right now, if I take this number right here, right? And let me just do both of them. So here, so we know there's a 2 there. So what's my A value?
4.
A value is 4. What's my N value? N is in Nancy. 2. That's the 2. That's on the outside. What's my M value? 3. There we go. So now let's just rewrite them real quick. So the first version is just 4 is my A, my M goes on top, so 3, my N goes on the bottom, 2. Oh, now we're good. That doesn't really help you solve. That's just rewriting it. Now the next version though, over here, I'm gonna write my square, my symbol, my radical symbol. 2 goes here, 4 goes here, and then in parentheses, 3. But here's what we can now do. What's in the parentheses? That's the square root of 4. Don't we know what the square root of 4 is? What's the square root of 4? So we could just say, okay, well, I know what that is. Like, I could solve that part real quick. And I would get 2. Now I don't really need the parentheses anymore. So it's just basically 2 raised to the 3rd power is my answer. So that's an example of a situation where by changing the format it's in, like doing this, I would have to multiply 4 out 3 times, then take the square root of that number, which would be 4 times 4 times 4 is 64. Square root of 64 is 8. Well, we just did the same thing, only we just had to multiply 2 times 2 times 2. It was a lot easier math, which again, not a big deal when you're dealing with really small numbers, like 4. But if that would have been a starting number of 16, and then obviously all our other numbers would have gotten bigger because we're multiplying 16 times 16 times 16, it would have made our math much easier, and we could have solved it really without a calculator even. So the final answer would be 8. And you might see it written as just 2 raised to the 3rd on a test. You might see it as 8, possibly. So just understand all the different rules behind how you would convert stuff. So that's really the new lesson. I'm going to go ahead and end for you guys here. Just follow along. You don't really have any more notes you'll have to take. If you want to have your phones out, just be on your phones. That's fine, since we're missing pretty much everybody. I'm going to keep doing the lesson though. So you can absolutely take a nap. You guys online, kind of the same thing. If you have work for another class, you're trying to wrap up anything for the last quarter, which is technically over, but some teachers might be letting you. I'm not. You can do that. If you weren't here, you need to watch, because I'm going over the stuff you missed last class. All right, so now we're going to talk about all of the different rules, the power rules for exponents. So let's go. Yeah, here we go. Practicing the rules. So again, this comes from your sheet. You guys that are online, there's a sheet you should have gotten in your email. I believe if you did not get this in your email, let me know. The top of the sheet says 5.2, so 5 dot, a little dot, and then the number 2, properties of rational exponents and radicals. Now I sent you guys the full document. You're really not going to need the full document, but I didn't have I do have that page in here. Good. I didn't have copies of all of it. I'm sorry, I didn't have a scanned copy of just the pages we were using. So I just sent you the whole thing. The main thing we're going over today is the very first page. It says using properties of rational exponents. And there's 1, 2, 3, 4, 5, 6. I think we only went over maybe 3 or 4 in this class. I might get through all of them though in the next 35 minutes, so we'll see. All right, so anyway, the first rule, it says product of powers property. If you don't have the sheet, that's fine. If you don't have the sheet, I'm just going to write the rule up first, so you can just copy what I write down. All right, so here's the first rule. And again, it's called product of powers property. A lot of times it's just called the product rule for exponents. So it says this. This is what she has written. I got this from another teacher online. And we actually talked about this in the bell work in our review. So it says if we have a problem and we're multiplying the terms together, so that's the first thing you need to realize, that these are being multiplied together. That's a little dot in between them. The next thing you need to realize is we have the same base. Has to be the same base. Again, write that down. This only applies when you have the same base. Really, any of the rules for exponents, you always have to have the same base number. If you don't, sometimes you can actually change the base to get the base numbers to be the same, which we'll get into maybe later this week. If not later this week, early next week. But you have to have the same base for any of these rules to work. So you're always trying to get them in the same base. So for example, just really quickly, I have this, but then I have that. I don't have the same base for all of those, but I do know that 4 is the same thing as 2 squared. So I could change this to 2 squared. Now I do have the same base. So that was an example of what I mean by sometimes you can change a number to get every base to be the same number. I just changed 4 into 2 squared. And now I have the same base in this bottom column. So anyway, have to be the same base. Have to. So if I do have the same base, what it's saying is all I have to do really is just I keep the base. You never do math between the base. So I don't multiply, like if the base was 2, I don't say 2 times 2 and then put a 4 there as the base. The base is just the base. It's always going to be the base. You never change that number. So write that down. Unless you change it intentionally, like you don't do math to it. So now we can just say, well, this is just equal to m plus n. We just add the exponents together.
What's up, Coach? Hey, Coach, sorry to interrupt. You wouldn't happen to have a green highlighter, would you?
Oh, maybe not. Not yellow. Right, purple. That's all I got.
Okay. I have yellow and I have pink. I just need a different.
Yeah,
color.
I don't. Oh, that's an expo marker.
Okay. I'll ask Miss Howard.
Yeah, any English people or Hauser would have one. Question? Talking about the highlighter.
I just saw a green marker.
That's dry erase. Yeah, wouldn't work. So anyway, so that's what the rule says right there. If we have the same base, we're multiplying terms, we can just add the exponents. This is by far the most important rule, just like I talked about earlier. Just like I talked about earlier, it is by far the most important rule, because if you understand this rule, and if you just understand that a to the 7th means a times a times a times a times a times a times a, if you just understand those two things, and if you understand this, I guess, that every number or variable or anything has a exponent of 1 on it, even if you don't see one there, there's an exponent, or when you don't see one there, there's an exponent of 1. If you understand those 3 things, you don't have to memorize all the other rules. It would be faster if you did, but again, when you go to take the end of course exam next year, you're not going to have the ability to recall everything you did. So if you can just focus on these 2 or 3 things, you should do okay on the exponent lesson next year. Or on my quizzes, you'll have the notes, so you don't really need to worry about it, because you can just look at your rules on your note sheet. So for example, if I have this problem right here, again, I always use 2's. So 2 squared times 2 to the 3rd. The rule says, because I have the same base, which is the 2, I can just put the base number and then say 2 plus 3, and that would give me 2 to the 3rd. That's what the rule says right there. If I did the math, you would see it works out, because that's a 4. 2 to the 3rd is 8. So that would equal, we can do that. That would equal 32, right? 4 times 8 is 32. Well, if I do 2 to the 5th power in a calculator, that's also equal to 32. I could even take this one step further. I'm going to go pretty fast, because again, this is a review lesson. We did this whole thing last class. If you weren't here, write quickly, or you can go back and watch the recording. So I could also say, well, wait a minute, this 2 squared, this first term right here, I could rewrite that really, because 2 squared is just 2 times 2. Well, then I'm just multiplying that. I'm just bringing down this multiplication symbol right here. Times, and then 2 cubed is just 2 times 2 times 2, 3 times. Well, again, going back to what I told you should be doing over and over again, every number, every variable has an exponent of 1 on it. So now I've got kind of a similar problem. I have the same base, 2, 2, 2, 2, 2. I'm multiplying them. So I could say, all right, well, I could follow that same exponent rule, and it would just be the base of 2, and then 1 plus 1 plus 1 plus 1 plus 1. I could add up every exponent. I can add up exponents for as many terms as I have, as long as it's the same base and as long as it's multiplication. So I had 1, 2, 3, 4, 5. So I added them 1, 2, 3, 4, 5 times, and I got that. So that's just an example of hopefully the level of understanding you will have. And if you have that, you don't have to remember the rest of the rules we're about to go over. Memorize, I should say. All right, so now let's go to the next rule. Oh, boy, it's going to erase everything on frame. That's okay. Oops. Oh, I didn't do that. All right, let's try that again. There we go. So now the next rule on that sheet. Again, this is coming from the 5.2 properties of rational exponents and radicals. It's a little packet, but we're just really using the first page today. So the next rule, it says quotient of powers property. It's really just called the quotient rule when I learned it, at least. Quotient rule for exponents, I guess it is about exponents, obviously. So it says this. I have this problem, a to the m. Again, a is the base, m is an exponent, a is the base, n is a different exponent. The quotient rule, because now we're dividing, so it's basically a fraction, but in a fraction, that line, any fraction, not just with exponents, that line means divide, remember? That's how you actually convert something to a decimal. If you have 1/2, the fraction 1/2, it's 1 divided by 2 gives you 0.5. So that line says divide. So that's why it's called quotient rule. So we're doing the quotient rule. Again, on the sheet, it's called the quotient of powers property, but it's quotient rule of exponents. This says, again, I take the base number. So a is the base, always stays the base. I don't do anything to try to divide the top a by the bottom a or anything like that. I just move the base over. And now I take the exponents and I subtract. Here is the biggest mistake I see on this by far. And somebody is guaranteed to make it, even though I've emphasized it every time I've talked about this. And I will emphasize it every time I talk about it. You take the top exponent and you subtract, so that's a subtraction sign, the bottom exponent. Do not just take the biggest number and subtract the smallest number. Kids always want to do that because they want the answer to be positive. You can get a negative exponent. There's nothing wrong with negative. I mean, actually, we don't like negative exponents, but they exist. They are real. Kind of like the M&M's guys in Santa Claus. They exist. They are real. So we always take the top exponent, subtract the bottom exponent. So now let's do a couple problems with this. I'll scroll down a little bit. So let's say we have this problem. Again, I'm using the same problems we did last class. So if I have not a, I'm using actual numbers, sorry. 2 to the 7th divided by 2 to the 5th. Well, again, the rule tells me if a is the base, then a is the same thing everywhere. So a here needs to also be 2. M, actually, here's a good habit to get into. Let's write it down. For this particular problem, A equals 7, M equals, I'm sorry, A does not equal 7. I'm getting ahead of myself. A equals 2. M is 7. N is 5. That's a good habit to get into, because then you don't get as confused about where stuff goes. Because I can just look at the final equation I'm using and say, okay, well, what is A? Well, A is 2, so 2 needs to be the big number. What is M? Well, M is 7, so go first. What is N? And I need to subtract. What is N? 5. So I really like this part right here. I didn't teach it that way last class, so that's kind of been added. For those of you that were here, you may want to add that to your notes. But just go ahead and define on the left, what is A, what is M, what is N. So that would give me 2 raised to the 7th. Now again, that's not a super hard rule to remember, but the problem is we're going to add more and more and more rules. So I want to show you why I say that the product rule is so important. The product rule was the one we just learned about multiplying terms. And then just also you have to understand what an exponent truly is. Let's look at this problem. Let's look at these terms. So I have that term and that term. Let's break those out and expand them into another format. So 2 raised to the 7th, let's change to blue. That's really just 2 times 2 times 2 times 2 times 2 times 2. Oh, and then one more. Here. So that's 7 2's multiplied times each other. And then that is divided by, so that line still means divided by. We just have to draw a really long line because we got a lot of numbers in the numerator. That's divided by 2 to the 5th, which is just 2 times itself 5 times. Well, if you think back to when we solve equations, our last step in solving an equation is always division. So if we have, for example, over here, 4x equals 8, we want to divide by 4 and divide by 4, and we get x equals 2. Well, the reason we divide by 4 is so that that and that cancel out. Technically, they both go to a 1, and we get 1 divided by 1. Well, 1 divided by 1 is just 1, so we don't really need it. We could keep it in there if we wanted. We could say 1x. Like if we wanted to, we could write 1x down here because we have this 1 divided by 1. But we normally just get rid of it. But we're doing the same thing over here. We have 2 divided by 2. So we can get rid of that. And we could say that's 1 and 1. That becomes 1 and 1, 1 and 1, 1 and 1, 1 and 1. So down here, we'd actually have 1 times 1 times 1 times 1 times 1. So we just have a 1 left down here. Here we have 1 times 1 times 1 times 1 times 1, but then times 2 times 2. So if we rewrote that, we would really just get 2 squared, because again, if I have a 1 and a 1 there, oh, they actually all had 1, so I want to get in that habit. I didn't 1 everywhere. So that's an exponent. The ones down here, by the way, hopefully this isn't super confusing, probably shouldn't have even written them in. These ones are when I cancel it out. When you cancel out the terms, the whole term goes to 1. It's not an exponent. 2 divided by 2 is 1. That's why I'm writing the ones down below. These green numbers here, these are the exponents. But again, 2 divided by 2 just becomes 1, so that's why I wrote those ones on the bottom down there. So that would be equal to 2 squared. So if you notice, we get the same answer. I didn't memorize the quotient formula. I just understood, well, 2 raised to the 7th is 2 times 2 times 2, 7 times up top. And then 2 to the 5th is 2 times 2 times 2, 5 times on the bottom. And then when I cancel them out, I'm just left over with 2. I'm just left with 2 2's on the top. 2 times 2. I'll give you a second to soak that in. If you want to go back, pause it, rewind it. whatever. I'm gonna do one more example. It's a little trickier. I guess I'll go ahead and I guess I'll erase just this part. I'm not really using. Oh, I erased too much. I erased too much. All right, so now let's do kind of the opposite problem. And this is the part where I told you people would mess up at some point, and they did when we did this in class, last class. Some people messed up. So again, I want to do that problem. I'm going to do the short version first, just using the rule. That says I take the base of, and again, I could probably say M is 5, N is 7, and now they've switched. So there's what all my different things stand for. So my base is A, so that just becomes the 2. Now, though, my M is 5, so it's the opposite. This is now a negative exponent. So we can get a negative exponent. It is possible, as you see right there. So I'm going to skip down now to do the negative power property or the negative exponent rule. It's the 4th rule on the sheet, on the packet, the front page. We don't like, now they exist, but we don't like them. I know you guys don't like dealing with negative numbers anyway. So we would really never want to have a negative exponent in a final answer. So there's a way to convert a negative exponent into a different format that has a positive exponent. And that's what the negative power property is, or the negative exponent rule. So so I'm just going to take the same answer I just came up with. And I guess I can just rewrite it down here. So I have 2 raised to the negative 2. So if you look at the problem, like if you look at what the rule is, tell you what, I'll write the rule out to the side. It says A to the negative M equals 1 over A, and then raised to the positive M. I am not going to worry about the rest of that piece for right now. In all honesty, I didn't even see that last class. We may come back to it, but this is the main thing I want you to understand. So all we did, again, if I just said, okay, well, in this problem, what's happening? Where's my base going? Well, if this was my base right here, I just moved that into a fraction and into the denominator. I put it under 1, so this top piece is always going to be 1. That is always going to be the number 1. 1 divided by, and then the base A. Then I took the exponent, and it's still the exponent, but I took away the negative. The negative sign is gone. Make sure you notice that. Because I told you in the beginning of this, we don't like negative exponents. So this is how we get rid of it. We make it into a fraction. So we put the base underneath 1, and then we put a positive exponent on that fraction. And that changes it into a number that now has a positive exponent. So I'm going to kind of go backwards, get rid of some of that. There, that's fine right there. So now let's take our example. So here, we have 2 to the negative 2. Let's identify, no, we don't have an N, we only have A and M. M is in Mary. So all we have to identify is what those stand for. So A is always the base. M in this case is the exponent, but we're not going to say it's negative 2. We're just going to say M is 2, just the number part. Boy, and that's going to be confusing, I know, because in the future you're going to probably do the same thing. Shoot. This doesn't work as well for this. Here, I'm not going to do this part. Let's erase that. Just use the formula on the right. Just use the equation on the right to rewrite it. So if I were going to take this 2 to the negative 2, I need to rewrite it by saying, okay, well, I need to, first of all, have a fraction with a 1 on top. That's always going to be the case, because the number you can't change the number 1 into something else if it's in the formula. Can't change the division part. So what needs to go underneath that 1? Well, A, whatever A is. Okay, well, A is the big number, the base. So that's 2. Then, here's where you're just going to have to make sure you remember to do this. The whole reason I'm doing this is to get rid of the negative exponent, but I still need an exponent there. So the exponent is positive 2. Again, just remember, write this in your notes like this if you want. Do that, and then you can write above it, change to positive. Change to positive, because it went from negative to positive. So something like that in your notes would work. So I'm going to kind of show you, again, why the product rule is so important. And I said you wouldn't have to memorize other rules. Let's say that we went back to the original equation on this, that right here. So let's say we're looking at this, original problem, not really equation, I guess. And we solved that out, and we got this, 2 to the negative 2. And then we fixed it by putting it over. Or we fixed it by, changing it to a fraction with a positive exponent. Well, the first thing I want to explain or make sure you understand is that this term, this answer, right here, this 1/2 squared, for some reason, when we put different stuff inside parentheses, it freaks kids out. Anything squared, doesn't matter how weird it is inside these parentheses, anything squared is just equal to that number, so in this case it's 1/2, times itself twice. So 1/2 squared is just equal to that. So we could say that's equal to 1. Oh, didn't mean to do that. We could say it's equal to 1/4. We could also say, I'm going to kind of squeeze this in, it's equal to 1/2 squared. Because remember, 4 is just 2 squared. So all of that is true. 1/2 raised to the second power is just equal to 1/2 times 1/2. Actually, I'm going to write this a little bit better so it's not quite so crammed. So that equals 1 divided by 4, which is really just the same thing as 1/2 squared. 4 is the same thing as 2 squared. So now, let's use the product rule. Let's say we didn't memorize the rules, we forgot the rules, we're confused about the rules. If I know the original problem was this, I could rewrite that again by just saying times 2 times 2 times 2 times 2 divided by 7 times, right? We have 7 on the bottom now. Well, again, some of these 2's are just going to cancel out and become 1's. So 2 divided by 2 is just 1. 2 divided by 2 is 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 1. So now we're only left over on the bottom with 2 times 2. So what's left over on the bottom? There's nothing on the top, but technically there's a 1 up there, because remember, all of these 2's up here, when we divided out, they all became a 1, because 2 divided by 2, let me just show you real quick. 2 divided by 2 equals 1/1, because we're technically simplifying, you could say, the fraction, and then 1 divided by 1 is just equal to 1. So when you simplify a fraction, remember, you divide the top and the bottom by the same number. That's how you simplify. So if I divide both of those by 2 to simplify it, I get 1/1, and that equals 1. So we have a 1 on the top. Just trust me on that. So if you'll notice, we got 1/2 times 2. I'm going to bring it down to there. So 1/2 times 2 is either 1/4 or 1/2 squared. just like we got up here. So I didn't have to use the quotient rule to still get the same answer. I just had to understand what 2 raised to the 5th is and what 2 raised to the 7th is. And then you do have to understand that you can cancel those out. And I was left over with the correct answer. And that also shows you that 2 raised to the -2, which is what we use when we use the rule, is the same thing as 1 over 2 squared, because that's what we got right here. So it shows you that's the same thing. Again, I know I'm going fast, but that's because we already did all of this stuff in most of the classes. I don't think we did it in every class. So I'm going to do one last rule, and then we're done for this lesson. And then I'll have recorded everything that I went through. So the last rule we're going to do, it's called the power of a power property. This one's pretty quick. So her rule says this: a to the m and then n. Now that looks maybe a little confusing at first. All she's saying though is we're taking some term inside parentheses, whatever this is. Could be 2 squared, 2 to the 3rd, could be 10 squared, could be anything. And then we're raising that term to another power. That whole thing is then getting raised to another power. So that's all this is really saying. So the rule is that equals, again, the base number is always going to be a. If you'll notice, base is always the same. Base is always the same. Base is always the same. Whether it's a number or a variable, the base needs to be the same. Otherwise, the rules don't work. And then we say, well, that equals the base, and the exponents you actually multiply now. So we've added exponents, we've subtracted exponents, now we're multiplying exponents. And I don't think there is a rule where you divide exponents, so that we really covered all of them. So let's do an example. If I have 2 squared, and then if I raise that to the 3rd power, actually here, I don't want to do it now. For some reason, I think this works out. There. If I have that problem right there, it's telling me the answer to that then is just, again, the base number is always the same. So I write down the 2. That's the A. A stays A. M, now here we could go back and do A is 2. M is 3. Actually, no. What is M? How did she write the rule? Oh, yeah. M is 3. N is 2. So I would write, all right, well, 3, it doesn't really matter because 3 times 2 or 2 times 3 would have been the same no matter what. So 2 times 3 is 6. So there's my final answer. Again, let's say I forget the rules and I forget, am I supposed to add those? Am I supposed to multiply them? I don't remember. Just focus on the other rules that you know, the basic rules. So again, this term right here, that is saying everything that's in parentheses needs to be raised to the 2nd power. Well, in parentheses is this whole thing. That whole thing is in parentheses. So we're raising that whole thing to the 2nd power, which means we're just multiplying that times itself. So this whole thing that I just, unfortunately I didn't, oh wait, go back. That whole thing right there is just really saying 2 to the 3rd. That's what's in parentheses. And then we're squaring that. We're just multiplying it times itself. That's all we're saying. Whatever's in parentheses, like we had 1/2 squared earlier. Well, that was just 1/2 times 1/2. 2 raised to the 3rd squared is just 2 raised to the 3rd times 2 raised to the 3rd. Well, if you remember, the product rule says if I had the same base, which I do, the 2, I can keep the same base, and I can just add the exponents. So I get the same exact answer. Same exact answer as I got up above. So again, that is why the product rule is so important. The product rule, and then understanding, you know, just the simple rules like this, or the simple rule that you know, a number raised to an exponent means you multiply that number over and over and over again times itself until you get to however many, you know, whatever the digit is for your exponent. So if you understand those three things, and then the stuff we talked about with radicals and how to rewrite them, although that's a little trickier, you should be in pretty good shape for the exponents section of the end of course exam, I think. I mean, it'll get a lot harder than that, but you should get some points for sure. All right, so that was right on time with the bell, so you guys can head out. I'll have
Go.
the copies made and get you the other packet you need for the rest of the week. I'm gonna go do that
Go.
now in my next class. Yes.
What packet were you talking about, or like the worksheet we're supposed to do again?
Well, you're not doing anything. They were just for notes. So it's the one that
okay.
I must have said it 4 or 5 times. 5.2, that one, and all these rules were on the very first page. It should have been in your email.
Okay.
If you don't have it, let me know, but I believe I emailed that out. And I didn't. No, you have a bigger packet than what we have in class because I didn't have an electronic copy, so I had to email you the full packet. Here, I just took some of the pages out. So you'll have more than what they have here, but that's fine. Just whatever page we're on, I'll tell you what the page looks like. All we've done is the first page so far. So.
Okay, thank you.
All right. See you guys.
Have a great day.
You too.